Welcome back to our 5-part series where we are celebrating the anniversary of Charles Lindbergh's historic solo transatlantic flight by modeling his iconic Spirit of St. Louis monoplane. In part 3 of this series, we're going to hollow out a portion of this fuselage, and we're going to model in the wing and horizontal and vertical stabilizers. We're going to add the window to the side of the fuselage, but first let's hollow out the center portion of this body. Let's split this body into 3 parts. We can do this with a simple line sketch. So let's sketch on the side face of the fuselage, and I'll just sketch 2 vertical lines, one snapped where the cowling terminates and another dimensioned 4.875 inches from the first line. With the sketch highlighted, navigate to Insert, Features, Split, and check the boxes next to the bodies you'd like to split. And we'll make sure the Consume Cut Bodies option is not checked. Now we can hollow out the center body using the Shell tool. Let's hide our other 2 bodies and navigate to the Shell tool in the Command Manager. I'm going to set a wall thickness of 1/8 of an inch, and on the model select the faces I'd like to remove. In this case, the 3 flat faces. And hit the green check mark to complete the operation. Now let's recombine the bodies by going to Insert, Features, Combine, or just select the Combine tool in the Command Manager. I'll ensure the Add option is selected under Operation Type. Select my 3 bodies and click on the green check mark to combine the bodies. Now let's cut out our window using a sketch on the right plane. I'm going to unhide our side view image to sketch on top of and sketch a simple rectangle. Navigate to the Extruded Cut tool and we'll do a simple extruded cut through all. Now we are ready to add in this half of the wing. Most aircraft have dihedral built into the wings, that is, they angle upwards slightly for added stability of the aircraft. But the Spirit of St. Louis is built with a flat wing, which is somewhat unique. So we can simply do a straight extrusion of this airfoil shape. We'll leave the side view image showing and sketch our airfoil shape on the right plane. Let's use a few simple splines to sketch the airfoil, using the imported image as a visual guide. I'm happy with the shape of this airfoil, so I'll extrude this just up to where the wingtip starts. In this case, 14.35 inches. We're going to add our wingtip using the Boundary tool, but let's create a few profile sketches prior to entering the Boundary tool. I'm going to create the wingtip in 2 halves, and I need 3 profile sketches, 2 on the face of this wing, and 1 perpendicular to the face. Let's first create a construction line on this face snapped to the front and rear points of the wing. Use this line to create a construction plane perpendicular to the face of the wing. Sketching on the wingtip face, I'll use Convert Entities to sketch 2 profiles in separate sketches. I'll draw the third profile sketch on the perpendicular plane we just created, using the top view image as a guide. and I'll set a few constraints to ensure this wingtip blends in nicely with the wing. Now we're ready to create our boundaries. In the Command Manager, select the Boundary Boss/Base tool. Under Direction 1, we will choose our top profile, and then select the horizontal profile. You'll notice in the initial preview that this will create an angular boundary, but we can control the shape of this wingtip without having to use guide curves. For each profile, you can use the drop-down under Direction 1 to control how the profile interacts with any intersecting planes or faces. These options will apply various tangency constraints to the boundary. With any profile that interacts with adjacent faces, such as with this top profile we've chosen, you have several options to constrain how this portion of the boundary behaves. You'll see the option for direction vector, where we can choose an entity such as a plane to get a tangency constraint, or we can simply choose normal to set this portion of the boundary normal to the profile's sketch plane. You'll also see tangency to face, which makes the adjacent faces tangent at the selected profile. And there's the option for curvature to face, which applies a smooth, curvature continuous surface at the selected profile. Since my main wing is a straight extrusion, I'm going to use the normal to option to blend the wingtip. And we can adjust the tangent length to control the amount of influence these tangency constraints have. Because our horizontal profile doesn't interact with any faces, you'll notice only the direction vector and normal to options are available. In this case, I'll choose normal to again and set my influence amount. There we have a nice rounded boundary. And I'll repeat this operation for the bottom half of our wingtip. Notice you have the option to boundary to faces, as I'm doing with this horizontal face, rather than the need to use only profile sketches. From this front view, you can really see how applying these tangency constraints affects the shape of the boundary. And because we've applied these constraints, we get a nicely blended wingtip. Before extruding the tail stabilizers, I'm just going to blend this wing into the fuselage using a 0.1 inch fillet. Most aircraft's horizontal and vertical stabilizers are built with an airfoil shape just like the wing, but for this 3D printed version of the Spirit of St. Louis, I'm just going to create these tail pieces using straight extrusions. Let's start with the horizontal stab. First, I want to create a flat spot in the fuselage for me to sketch on. So let's sketch on the right plane and use the side view image as a guide to cut away a portion of the fuselage. Actually, rather than use the extruded cut, I'm going to use the split tool again, as I want to keep this portion of the fuselage to recombine later. With our new sketch highlighted, navigate to Insert, Features, Split, and click on Cut Part, and choose which of the resulting bodies you'd like to split. You have the option to choose just one of the resulting bodies and keep the Consume Cut Bodies option selected, but in this case we want to keep both bodies, so I'll turn off Consume Cut Bodies, and I'll hide my split body. Now we are ready to sketch on this new horizontal face. I'll unhide the top view image to use as a guide for sketching the horizontal stab shape, using a series of lines and splines. Let's extrude this 0.1 inches And I want to turn off merge result so I can split the elevator from the stabilizer and apply fillets to the new bodies. Now I'll just apply a 0.075 inch fillet. I've shown you how to use sketches to split bodies, but you can also use planes to apply a split. Let's navigate to Reference Geometry, Plane, and select this small face where the elevator and horizontal stabilizer connect. And I'll set the offset dimension to 0. Again, under Insert, Features, Split, this time I'll select the new plane as the trim tool and choose the bodies I want to split, turning off the Consume Cut Bodies option once again. Now I'll just apply a 0.075 inch fillet around both of these new bodies. To wrap up this portion of the series, let's extrude our vertical stabilizer and rudder. This time I'm going to sketch them separately rather than split the body. When extruding the vertical stabilizer, I'll leave Merge Results on, and under Feature Scope select only the horizontal stab to combine the two bodies, so I can fill up the edge where they interact. And I'll sketch the rudder. And notice, when I'm using splines, I don't sketch in a ton of control points. Instead, I just sketch in a few control points and use the handles to come to the shape I'm happy with. This is best practice for splines as it helps maintain a nice smooth curve and it requires less computing power. So let's extrude the rudder, this time making sure Merge Result is not checked. And I'll apply fillets all around, similar to how I did with the horizontal stab and elevator. Now we can combine the stabilizers to our fuselage. I'll leave the elevator and rudder disconnected, as I'll print those as separate parts and join them using hinges. Now we have our basic parts of Lindy's aircraft built in, and we're ready to move on to part 4 of the series, where we will use a series of sweeps to model the Spirit's unique strut structure. Stay tuned.